In Aotearoa, building sites are our biggest rubbish makers. Construction and demolition generate about half of everything we send to landfill. Each new home adds roughly 4 tonnes of waste. Over the next 35 years, the United Nations predicts that we need 230 billion square metres of new buildings, essentially adding a city the size of Paris to the planet every week. We must change. We can't continue building this way. Join me for the short taster lecture on the future of the construction industry, why it needs to change, how low carbon materials are reshaping what we build, and how digital tools are empowering that change. Kia ora. I'm Antony Pelosi, a senior lecturer in architecture and construction at Te Herenga Waka, Victoria University of Wellington. Think about the last building you saw being constructed. Now think about all the waste, timber offcuts, plasterboard, plastic wrap, and the truck-sized rubbish bins. Multiply that scene across Aotearoa, and you'll see why construction and demolition rubbish now accounts for about 40 to 50% of everything we send to landfill. On top of the amount of waste, the construction industry and the built environment contribute nearly 40% of global carbon dioxide emissions. Most of this stems from energy-intensive materials such as concrete and steel, as well as inefficient building processes. What if digital design and low carbon materials could shrink that mountain of waste to almost nothing and even make tomorrow's buildings regenerative so they are waste free and help the environment rather than damage it? We have to reduce the embodied carbon in new buildings. Embodied carbon is the greenhouse gases emitted to produce, transport, and assemble materials for buildings. One way to do this is by using low carbon materials such as bio-based or recycled products like timber and hempcrete that dramatically reduce embodied carbon in buildings. The use of digital construction is helping improve how we build. Digital construction is all about data-rich building methods, digital twins, generative design, and robotics that help reduce waste and speed up time and lower the cost of quality construction. Our challenge, as set by the United Nations and the New Zealand government, is to achieve net zero construction by 2050, while still meeting the demand for homes, hospitals, and other infrastructure for a growing population. We have to do things differently. Let's take a look at some examples of construction innovation happening right here at Victoria University of Wellington. Firstly, we have the reusable timber system X-Frame, developed within the School of Architecture. X-Frame is an award-winning modular timber framing system that allows walls, floors, and roofs to be clipped together, taken apart, and reused almost indefinitely. By turning every panel into a recyclable building block, it pushes prefabrication into a true circular economy model, slashing on-site waste, cutting embodied carbon, and influencing sustainable construction practices. We also have digital twins. By creating detailed digital models of buildings, we have live 3D information about the project, letting the team detect clashes, which reduces cost and embodied carbon while tracking construction progress and managing building maintenance. Last but not least is robotic manufacturing. In our workshop, we have a large robotic arm that can take a building's digital twin directly from the computer and use it to cut, drill, and fit timber panels together with millimeter accuracy, helping to reduce waste and improve quality. Imagine the pride of knowing your first job might be helping build a net zero school or hospital, structures that store more carbon than they produce. Think about telling your family you've helped program a robot that cuts timber frames that eliminate tons of waste. You wouldn't just be working on buildings, you'd be creating legacies, spaces where people thrive and the environment heals because your skills made it happen. Transforming construction isn't optional, it's essential to meeting New Zealand's net zero goal by 2050, while creating resilient, beautiful places to live. The future of construction will be lighter on the planet, smarter with more data, and richer in opportunity. Will you help craft buildings that give more than they take? Study for a Bachelor Construction at Te Herenga Waka, Victoria University of Wellington.